But explain this concept of irreducible complexity.
Right. The case for intelligent design is not so much made in the negative as, well, it's so complex it couldn't have arisen by an undirected process. It's really made in the affirmative by noting features in living organisms that we know from experience are produced by one and only one type of cause. One of those features is digital information. Okay, and that's the argument that I've developed. Mike Behe has developed a separate argument.
One which I called irreducibly complex, or something that had the property of irreducible complexity. Now that's a fancy phrase, but it stands for a pretty simple idea. It just means you've got a machine or a system or something that has a number of different components. And all the components interact with each other to do something, to produce a function that the individual components can't. And again, that's some words that it's better oftentimes to see an example. And an example I like to show of such a thing from our everyday world is the following. And this is just a simple mechanical mousetrap, one you'd buy in a grocery store, say. And as you can see, a mousetrap has a number of different parts. It's got that tightly wound spring in the middle, and if you look closely, the top end there is extended so that it presses against the wooden platform. And at the other bottom end, another extension of the spring, the metal overlaps this other metal piece, which is called the hammer, and that's the piece that actually squashes the mouse. And when you push the hammer over, it's got to be stabilized in place until the mouse comes along. That's the job you see in the lower right there of the holding bar. And the holding bar inserts into something called the catch in order to stabilize it. Now the mousetrap needs all these parts to work. If you took away the spring, if you took away the catch or the holding bar or any of the parts, then you would not have a mousetrap that worked half as well as it used to, or a quarter as well as it used to. You'd have a broken mousetrap. It wouldn't work at all. So this is what I mean by the phrase irreducibly complex. This is an example of it. Now it turns out that things like this are big headaches for Darwin's theory, because if you wanted to evolve something like a mousetrap by something like Darwin's mechanism of numerous successive slight modifications, how would you do that? Where would you begin? Would you say, start with just the wooden platform and hope to catch mice, say, inefficiently? Maybe they'd trip over it as they ran across the floor or something. And then maybe you could improve it. Maybe you could put a kind of a thin piece of metal like what would be the holding bar onto it. And then maybe as they tripped, they might impale themselves on the holding bar. No, that's silly. That wouldn't work. And that's the problem with irreducibly complex systems. You can't make them gradually. They only work pretty much when the whole thing's put together. So natural selection wouldn't have anything to select until the whole thing was put together. So that's a problem. Well, okay, mousetraps are interesting. I spend a lot of time thinking about them. But the real question we want to answer is, are there any irreducibly complex biological systems? And especially since modern science has shown that the kind of foundational level of life is the cellular and molecular level, are there any irreducibly complex cellular or biochemical systems? And the answer is that, yeah, they're all over the place. You can't turn a page of a biochemistry textbook without coming across examples. And my favorite example, makes a good visual example, is shown here. This is a drawing of something called the bacterial flagellum, taken from a popular biochemistry textbook that's used widely in the United States. And the flagellum is quite literally an outboard motor that bacteria use to swim. And just like an outboard motor in our everyday world, it turns a little propeller, and the propeller turns around and around and pushes against the water, and then pushes the bacterium forward. And that squiggly part on the right-hand side, that acts as the propeller, and it's literally turned around and around and around. And the propeller is attached to the drive shaft, which is that yellow rod there in the middle, by something called the hook region, which is the orange part, kind of a little above that. And the hook region acts as something called a universal joint, which engineers will know can transmit the motion of the drive shaft into a different plane that allows the propeller to spin. And the drive shaft is attached to the motor, which uses a flow of acid from the outside of the cell to the inside of the cell to power the turning, kind of like water flowing over a dam can turn a turbine. And the whole thing has to be kept stationary in the plane of the cell membrane, and that's the job of some of these parts on the bottom that act as a stator. And there's many other parts too, and all of these parts which are drawn as little cartoon geometric figures are actually themselves very complex pieces. I like to show people this drawing of the flagellum because most people, when they see it, quickly realize that this is a machine. This is not like a machine. It is not analogous to a machine. This is a real machine at the molecular level. And from what we know about machines, that can give you kind of a clue about what is required to make one. Well, maybe you can see from looking at it that, like a mousetrap, the flagellum is irreducibly complex. If you take away the drive shaft, if you take away the hook region, if you take away the propeller, the flagellum fails to work. And so it too is extremely difficult to explain in terms of Darwin's numerous successive slight modifications. And in fact, nobody in science has explained how that could come about. Well, you might ask, is this some kind of freak of nature? You know, is everything else relatively simple, and then we see this? No, it turns out that things like this are everywhere you look at the cellular and molecular level of biology. Just as an example, here's the cover of an issue of Cell, which is a journal for professional biologists. And if you can see, the issue is entitled Macromolecular Machines. And if you look at the titles of the articles on the table of contents, you see things like the cell is a collection of protein machines, polymerases in the replosome, machines within machines, mechanical devices of the spliceosome, motors, clocks, springs, and things. Things like this are all over biology. So the point is that there are structural obstacles, there's physical reasons to think that Darwin's theory really can't do what its proponents claim for it. But again, you know, in our everyday life, we hear it claimed repeatedly in the media that Darwin's theory has been shown by science to be able to make everything in life. So the next point is to say that those grand Darwinian claims rest on undisciplined imagination. Now, imagination is a good thing in science, as it is in many other enterprises, but if it's undisciplined, if it's too far removed from the data, then it can become misleading.